Hello everyone. Today we're going to start talking about C++ standard library. C++ is an advanced high-level language. It is high-level, which means you can easily get something to work. It is advanced, which means you could also very easily to do things in the wrong way. This is why we need a library. And C++ standard library is one of the most crafted libraries out there. And the standard temporary library is at the heart of C++ standard library. And that's what we're going to talk about today. So what is in standard temporary library? Standard temporary library has algorithms and containers. The containers contains data, and algorithm operates on the data that's in containers. So you can think of it as data structure and algorithms. The idea of object-oriented programming is to combine algorithm and data into a class, which is so-called object. Standard template library kind of goes the opposite way of object-oriented programming. It separates the algorithms and the data structures. The purpose of that is for code reuse. We want one algorithm to operate on different containers, and we want one container to be able to use different algorithms. However, the containers have different interfaces from each other. So if I want to apply one algorithm on different containers, I'll have to provide different implementation for that. So if I have n algorithms and m containers, I will end up having to provide n times of m implementations. That is quite a lot, and it is not scalable. To solve that problem, STL library provides another group of modules. It's called iterators. Each container is required to provide a common interface defined by iterators. Iterator can iterate each item inside a container. So the algorithm, instead of working on the container directly, it only works on the iterator. So the algorithm doesn't know anything about the container that it is working on. It only knows about the iterator. That will dramatically improve our level of code reuse. Instead of writing n times of m implementation, we only need to provide n plus m implementation, which is much better. Another good thing about this kind of structure is it is easily extendable. If I define a new algorithm that operates on iterators, then all the existing container can use that algorithm. Similarly, if I define a new container that provides appropriate iterate interface, then all the existing algorithm can be applied on that new container. So as you see, this library is very much reusable. However, the reusability comes in with the price, which is the library is not so easy to use. There are many pitfalls and traps. Today we're going to have an overview of STL library and talk about the pitfalls when we encounter them. We'll start by looking at a hello world kind of program that uses STL library. The first thing you might notice is the using namespace stud. Everything inside STL library is defined inside the namespace stud. So for the rest of the video, I'm going to assume that this using directive is used. First, I create a vector of int. A vector is a dynamic array that can grow. It is dynamically allocated on the heap, and the size of it is not fixed. Vector has a member function called pushback, which appends an element to the end of the array. So for the vec, I push back 4, push back 1, push back 8. I end up having an array of 4, 1, 8. So the sequence of the element in the vector is defined by the sequence they are pushed back. As we said, each container is required to provide an iterate interface. So vector has a member function called begin and a member function called end. The begin will return the iterator that points to the first element of the vector, and end will return the iterator that points to the end of the vector. And with the iterators, I can use a for loop to iterate through each element inside the container. So for vector int iterator, so the iterator is a type that's defined inside the vector. Iter equal to iter 1, iter not equal to iter 2, and plus plus iter, and then print out the content of the iterator. So as you see, an iterator is just like a pointer. You can assign one to another, you can compare them, you can increment an iterator, and you can dereference an iterator. So even though iterator is a class, it behaves just like a regular pointer. Another thing to note is the function of begin and end defines a half-open range. It includes the first item that's pointed to by begin, but it doesn't include the last item that points to by end. So this is the mathematical notation of it. Looking at the picture, vec.begin points to the first element in the vector, and vec.end points to one spot after the last element in the vector. This is a very important concept to keep in mind. So if I try to dereference vec.end, ouch, that's undefined behavior, a very dangerous situation that you never want to get yourself into. Now we've seen the container, the iterator, and here comes the algorithm sort. As we said, algorithm does not work on containers directly, it works on iterator. So this sort function will sort all the elements in the range from iter1 to iter2. In this case, the entire vector. After sorting, vec contains 1, 4, 8. So this small program demonstrates how the containers, algorithms, and iterators work together as a team. Many people have rarely used C++ standard library. They prefer to write everything by themselves. Actually, majority of our C++ program should be using the standard library. There are good reasons for that. Number one is code reuse. There's no need to reinvent the wheel. Number two, efficiency. The library is very fast and efficient. In majority of the case, it's more efficient than the code written by you. And because the library is so important, modern C++ compiler are usually tuned to optimize for C++ standard library code. Number three, they are accurate and less buggy. They do what they say. Number four, they can simplify your code. They can reduce the control flow in your code. Besides, the library interface has very good names. Once you get used to them, your code is actually very readable. Number five, it is a standardized library, which means it is guaranteed to be available. Number six, it's a role model of writing good libraries. Lastly, a good grasp of the standard library, especially STL, means a good grasp of data structures and algorithms, which will put you in a good position when you interview for a job. So these are the reasons why you should learn C++ standard library. If you don't learn them, you don't know what you are missing. Next time, we'll start talking about the details of STL. That's all for today. Thank you for watching. Feel free to subscribe to my channel so when I post a new video, you'll be notified. Or you can go to my channel's homepage and see what I'm offering today. Bye bye.